Hello, everyone. Welcome to ITS 520. All right, so just a few announcements. So number one, keep in mind you have the practical exam for Twitter. I've gotten some emails about it, that you were having some issues, some delays with getting the Twitter IDs, the codes and everything. Some of you started sending me emails that you've gotten them, Wednesday, Thursday, Friday, Saturday, and so on. So it's varied. So because of that, I'm going to give you guys more time. So I'm going to extend the practical exam until 1 week. So I'm going to give you 1 week more. I mean, with me, I'm not really, what I'm concerned about is that you learn things, right? So, so that's, probably due to the election or something, they've been a lot more, I would think actually, they would be surprised that a lot of people just a few weeks before the election were requesting accounts. And so I'm sure they were more careful with that. So, therefore, but I have heard from you guys, Mitch and other people, that you have been receiving, you have gotten your accounts now. So some of you have already started the exam. And so given that, I'm just going to extend the deadline. So let me do that actually now before I forget. So I'm going to give you 1 extra week. That's going to be, so it's going to be due on the 9th, still by 11 p.m. And then also the end date will be the 9th. So 9th, yeah. All right. So that should take care of everything as far as the practical exam. So please, do a good job, right? Do a good job. That's really, I'm looking to see if you're, this particular skill, let's put it that way. The particular skill of you find a problem, like let's say the election, right? Who's going to win? And then there's a medium out there. You've heard obviously that everybody says data is so important. Data is so important. They say the new commodity is data, right? Worth almost as much as oil or more so. And so you want to understand what they mean by that. And what they mean by that is you have a problem, let's say, and it doesn't have to be the election. This is just an example. So who's going to win? So then you say, well, how do I do that? Well, maybe I could build a classifier using tweets, and then I predict leaning this direction, that direction, right? So you got to formulate the problem first. So I want to see that logic that you follow. And then after that, use all the tools that you've learned. And then, use, sklearn, Weka for the machine learning. But, before you do that, you need a data set. And before you do that, you need the features. Okay, so you need to identify, remember, I'm evaluating your understanding of X and Y. X is made up of samples, features. What are the features? Would more features help? Maybe, right? You got to do experiments. You got to try these things. Okay, and then there's the labels. You have to annotate. And I gave you some hints on how to do that as well, based on the keywords. I think I had a question on the 2 Twitter scripts. So why do you have 2 Twitter scripts? So there's 2 Twitter scripts because one of them gives you, and you can see them here. So you should be able to see this file, Twitter text, and then the other one, I think, I don't know why. This thing's strange sometimes. Give me a sec. All right, so you should be seeing my bright space. All right, and then the other script, they're both for one is for actually retrieving tweets. Remember, Twitter sells these tweets, so they're not just going to give them to you, but I think they, at least in the past, it's always been that they would give you about a week's worth, which I think is, if you think about it, it's like 100 tweets per day. So that should be 700 tweets. That's a good number. That's why I said, 300 per label. That's roughly about 900. And just depends on the terms, the keywords, etc. So one gives you the tweets, and it should work pretty straightforward. Now, figure it out if it's not, but it should be pretty easy. The other one downloads metadata about Twitter and tweets. So instead of downloading the tweet itself, it'll download, what do you call it? Like likes, retweets, followers, those kinds of things. So you have the metadata, you have the tweet itself, tweet themselves. You got to figure out, because it's two scripts, you kind of have to figure out how to get the same tweet. Tweets have an ID, so maybe you can download the IDs, match them somehow, and you could use both the metadata and the text itself as features. So it's up to you how you do it, but you just have to make a logical argument, and then I'll ask you questions about that. All right. Anyway, I think those were the questions that I had. So again, I've extended the deadline for the practical exam, getting the data from Twitter. Now you can go ahead and work. Got one more week for it. Another announcement is, please make sure that you are working on your term project, at least thinking about it. What are you going to do? So remember, I think I said form groups of 2 or 3. It's going to be mainly supervised learning, okay? Because that's really all we've had time to cover this semester, and so we can't really, we're going to run out of time. Although at the very end, the last 3 weeks, 3-4 weeks, I will cover reinforcement learning, and I will cover unsupervised learning. We'll cover those. All right, so that's the topics there. The other thing, the exams, so hopefully I'm still grading those. I will hopefully have those graded by tonight or tomorrow, hopefully. So I'm definitely shooting for that. So be expecting your exam later tonight, this evening, or after the class, or by tomorrow at the latest, hopefully. So you should have that.
Professor, how many more assignments are there going to be, like after the Twitter assignment? Are there going to be some more assignments before the final project?
That's a good question. So the Twitter is not an assignment, it's an exam, right? So think of it as a practical exam, like a take-home exam. Okay, so I'm going to, it's an important thing. It's going to be worth more than just the lab. It's a little bit more. The question was, will there be other homework assignments? There will not be a homework assignment today, because today we're just going to get into, what I've been talking about, TensorFlow and Keras and all that. But yes, there might be a homework assignment, or 2 or 3 before the lab. I mean, what do you call it? The project. Yes.
All right, got it, sir.
Okay. All right. Any other questions?
Yeah, I have a question. So
Yes,
with the Twitter exam here, I think I was able to do part 2, get the tweets and stuff, and run some analysis on them.
Yes.
I don't get part 1, what you want us to do in Excel.
Right. So, yeah, that's a good question. So let's open up the Word document. Okay. So are you guys seeing the Word document now? Can you guys see it?
Yes.
Okay, I'm moving it. All right. So, so basically, there are 2 problems, right? So the first problem is you can use the sample file provided, which is what I mean is the code. Search 3 terms on Twitter, right, and download their contents into a text file. clean the data, open the files in Excel, and run some general statistics. Look for insights about the search terms given the statistics. So this refers to the metadata. Remember I just said that there are 2 Python files? And so one of those Python files downloads the tweets themselves. The other one downloads metadata about tweets, and it downloads them conveniently in a CSV. So you should be able to open it as an Excel spreadsheet. So what I meant by that is just run some statistics. See if you can find, it's data mining, right? So that the reason why this is there is it's data mining, data analytics, data science. So it's not everything is, a classifier, for instance. So just take a look. Usually what you would do is you would take a look at it, look at the data, try to do some simple statistics, averages, etc. Maybe a histogram. So it's a similar idea to what you did with the frequency counts, but with this metadata. So maybe you download for a specific term. Let's say that you download. So you could download, what I would suggest, for instance, you could download 3 spreadsheets, right? One for this term, one for that term. So for instance, again, I keep saying this, but Republican versus Democrat. So then, okay, you do a pie chart of Democrat had on this day retweets versus Republican had this pie chart slice retweets. And then you do the same for, likes. And, it's just a way of saying, I looked at the likes on, what is today? November 2nd, right? I downloaded tweets that said, Republican, or a specific term that you think is trending, whatever. And then you download, you can look at the retweets of that term and the retweets of the other term on that day, create a pie chart. Maybe that gives you some insight, maybe not. I mean, but that's what I was asking for. Does that answer your question, Joe?
Yeah, I was a little confused because I thought we were, I was trying to do something with the tweets and do like count words and make a histogram and blah, blah, blah. Yeah, I was totally on the wrong path. So this sets me right. Thank you.
Okay, yeah, so this is just because you do have metadata, and metadata has value. Don't think that it doesn't, all right? It has a lot of value. I mean, I assure you there would be some marketing people that would be fascinated if you just took some terms and did a pie chart, and on this day, hey, look, your word is trending versus that other word that didn't trend. And so they can, based on that, they can adjust their marketing campaign because they're going to say, you know what, this really took off. Boom, let's go ahead and create policy based on this term. Does that answer your question, guys?
Yes, sir.
All right.
And for the second part of the question, we need to use both the files, right? The metadata and the
Yeah,
first
so
file.
for the number two is, now this one would be a classifier, right? But you can use the metadata. So if we look at problem 2, use the search code provided by the instructor, right? So you can use both you can use both Pythons or just one, but definitely one of you should at least use the text, right? I would suggest adding the metadata as well. I want to see how you do that. Search again, 3 terms. Excuse me. Hint, use these as labels, for instance, but you don't have to. I mean, you can be creative on Twitter and download the corresponding tweets. Again, you got to clean and tokenize the data. Then calculate the frequency of the most common terms. You know how to do that. Look for insights about the search terms, given the most frequent terms. So that's the same thing. And then collect about 100 to 300 tweets for each term, right? So it's a 3-class problem or a 2-class problem. But yeah, I just want you to have a good number of tweets in there. Okay. And then it says, You're going to create a corpus. So every sample would be a tweet, I assume. So create a corpus using these tweets by applying your knowledge of the vector space model. What I mean by that is the VSM lectures and also count vectorize, right? I gave you that code. You know, if you don't understand it 100%, you know, just keep, it's explained more in the book, remember, you can hold it, but you know, I gave you some code examples of how that works. And then you identify what are the features, what are the samples, what are the labels. You know, you got to give me those statistics. I want to know how many samples did you have, how many features per vector, you know, what are the number of classes. And then using this corpus, perform supervised machine learning using both sklearn and Weka. You know how to use both of these because you had that other homework. And then compare at least 3 algorithms. I should say at least 3 algorithms. And then you don't have to do the t-test, but you can just, you know, compare them experimentally and then compare your results using the performance metric. So I want to see precision, recall, F measure, accuracy, and the confusion matrix. And then also in Weka, as you know, you can do feature ranking quite easily. So, and then present your results. And that should be it. That should be it. Okay, and then make sure again you got 1 more week on this one. Do a great job. Okay, I'm really hoping to see great jobs here on this. And then that, you know, that'll complete that part of the class. And now we can look at the more advanced things. So this is a good lead-in. As you can see, we've covered Weka, we've covered sklearn, which are pretty easy. Now we're gonna continue our discussion of, you know, TensorFlow, in particular TensorFlow 2. In this course, we're doing mainly Keras. And so today I'm just going to continue with that topic. Okay. Yeah, go ahead.
I have a question. Do we have to use your code?
As opposed to what?
Or we can use our, I mean, searching for different codes if they work. With this, your assignment for first and second part?
I guess. I mean, if you want to write, but it's got to be.
As long as it satisfy your requirements.
So what are you going to use?
Oh, I'm not sure. I haven't started yet, but I'm just saying if we find.
Well, here's the thing, though. If you just give me a whole bunch of code that I feel that you don't know how to use, I will question you very, you know. So you make sure that any code that you use, you know what you're doing. Because, sure. Yeah, because if you just find something online and you think, oh, this kind of does that, and you submit that, you know, if you submit something that I know I taught you, you know, but otherwise, if you're using Python, okay, yeah, that's great. But if I see you, for instance, doing this assignment like in TensorFlow 2 or something, I will know that, you know, we haven't even covered the topic. You understand?
Yeah.
Try not to deviate, like using R or using Java or something like that. Try to stick with the programming language of the class. Okay, so definitely strongly encourage you to use Python. If you want to do it in C, C++, do it, but that's, you know, that's just 100 times harder. So at your own, do that at your own risk. All right.
Okay. Thank you.
Any other questions? All right. All right. No questions. All right. Great. So today then, I've received a lot of emails that Scholar is going to be getting maintenance tomorrow. So apparently it's going to be out all day. But today, from what I understand, it's working. So let's go ahead then. And if there are no more questions, let's go to Scholar. So let me just go back, do one more thing. I'm going to go to you should be seeing Brightspace now. And in Brightspace, so we're currently here in this module, TensorFlow 2 and Keras. So I'm just going to click on it. And if you notice, if you click on the link, that's basically all you need for this week and next week. I provided all the code already. So you should be seeing my GitHub now with the link. And basically here, that's what we're going to do today. General examples of how TensorFlow 2 works. In particular, we're going to use, we'll do some TensorFlow basics, which I've already started. Then we're going to do Keras. Then we're going to do the functional API, and then subclassing. So these are basically the same, the main ideas that we need to cover in the next couple of weeks. And as I said, all the code is there. So I'm just going to, as I write it down, I'm going to explain it. And I grouped it into these basics, functional API, Keras, and then I have some images. So if you notice, all semester, we pretty much just focused on data sets that already existed or text, right? So, it's been text, tweets or, just writing sentences, etc. Today, I'll show you how to process images. So as you know, images is a big thing out there for machine learning. You want to find pictures of cats and dogs or things like that. And so that's one of the things that we will do. So we will need these images. And then today we'll probably just get into basics. If any, we might get into Keras a little bit, but there's a lot of material here that we need to focus on. And then the next folder we will look at will be the Keras examples. If you notice here, I have the Keras multi-layer perceptron for the iris data set. And then I also have an XOR problem, the classic XOR problem that should be pretty good for understanding a lot of concepts, not just about Keras, but about machine learning as well. So we'll take a look at that. And then finally, the last thing we will cover is the functional API, which is, definitely a much more advanced topic, estimators later, but functional API certainly is essential, subclassing, because a lot of code is written this way, okay? A lot of code, all the advanced algorithms like transformers, etc., that are coming out now, they're all written in this approach, and so we're gonna look at it. So that's really the plan. Today we're just gonna continue with the basics. We're going to do examples of a lot of things that you need. So really, it's about the pipeline, right? So today is about the pipeline and various elements, as you can see, dealing with images, processing the images, how do we get the images into an X and Y matrix, and so on. Okay, so that's really our main goal. All right, so we're going to go ahead and please go ahead and start your Scholar device. I'm going to do the same. So I'm going to open Scholar. How do I open Scholar? There we go. All right, so we're going to log into Scholar now. All right, so you should be seeing Scholar for me. Okay, there we go. Okay, so if you've downloaded an older version of the repository, this is not going to work because I've updated the files. So I've updated the files. So we're going to do a fresh download of them. And then we can just get started. Web browser. So I'm going to use this as reference because I don't really want to type everything. I'm going to type certain things that I feel are good for like explaining, but I'm not going to, some of it I'm just going to copy paste, and I'll leave it as an exercise for you to figure it out. So how do I, okay, great. And then this should be, I assume, in downloads. Oh, I got all of these. All right, let me do that again. All right, there it is. So all right. So I believe you guys are seeing my desktop. So this is what you should be doing, downloading the files. Okay, so now if you look in here, the things that we're going to need are in Tensorflow 2 folder, general examples, and basically, I guess we can copy all of it, I guess. You're definitely going to need the images. So I'm going to copy that. And since I've been using this 520, create a folder. TF2 basics. Right. And then I'm going to create that. Also, I'm going to extract the images, so please go ahead and do that. All right, and the images, as I said, it's another type of data, okay? So we've done, so you guys should be seeing my folder where I'm showing some images. So in this images folder, I just opened it. And just like we did with text, and we had a lot of text, and text, every sentence or every tweet was a sample. Here I have fruit, basically. And you can see I really just, I kept it pretty simple. I only have 2 types of fruit. There are, in fact, 5 apples and 5 bananas. So basically, I have a balanced data set. So how many classes do I have in this data set? How many classes do I have?
You got 2 classes.
2 classes, right? What are they?
Apple and banana.
Apple and banana. And in fact, the name of the class is in the name of the file. So that's pretty convenient. Notice, they all start with apple if they're apple, or they all start with banana if they're banana. So that's a good way of labeling them, right? So you either put them in individual folders. So I could have 2 folders, one of all apple, one of all banana, and that's a way to know. Or I can label them, automatically somehow, you put a subscript of apple versus banana and so on. All right, so that's what we're going to see. It actually takes a bit of work to do this. One important thing is you usually want your images to all be the same size. So if you remember, the dimensions of MNIST were 28 by 28, a 2-dimensional grid for handwritten digits. However, just by looking at them, who could tell me, so if we look at this picture, right, and I do like properties, right, you know, that's kind of where you can start. You can look at the size, you know, see if the dimensions are there, you know, oh, there it is, 100 by 100 pixels. How convenient. If I look at another apple, okay, image, ooh, 100 by 100 pixels. So these are larger than MNIS, which were 28 by 28. All right, if I look at the bananas over here, what's the size? 100 by 100. Look over here, you know, image 100 by 100. Okay, how convenient. However, you know, I want to stress that this is really important because there are several things. Obviously, they're color images. So what does that mean versus how are these color images different from the MNIS data set? Where the MNIS data set, we know they were 28 by 28. These are 100 by 100, but these are color, not grayscale like MNIS. So what does that mean in terms of dealing with this data and your feature vector? What does that tell you?
There's going to be an extra dimension because of just color.
Exactly, there's going to be an extra dimension. These are, you know, they will have three. And that extra dimension, there will be three entries, one for red, one for blue, and one for green. RGB, what's called RGB. Exactly, very good. So that's going to then affect the size of your vector. And sometimes having color is a really good thing. But basically, when we translate these from their format as JPEGs into Tensorflow, these are not going to be grids of 2 dimensions, right? And you know, they're not going to be like planes, you know, just flat planes. Instead, now they're going to be cubes. So if you remember like a Rubik's Cube, right? You all played with that when you were little. And so, but a Rubik's Cube that only has 3 slices on that 3rd dimension. Okay, one for R, one for G, and one for B. So another way is to imagine that you have instead now 3 additional planes, and 3 planes make a cube. Another way is thinking it. Imagine if you have you know, DVDs, right? You have 3 DVDs for you know.
You sound like a robot. You need to fix something there, I guess. Professor, your sound is like a robot sound. We don't know, it's double. I don't know what you're saying. Is that just me or everybody, I guess?
I mean, it was like that for a while, but it's good now, I guess.
So is it still bad or is it?
No, it's still bad.
How about now?
It's the same.
Can you hear me?
Yes.
Does it still sound like a robot?
Nope. It's much better.
Oh, it's better now. Okay.
Yeah.
Okay. All right. So, well, let me know. I don't know what to do about that. I mean, I honestly, just as soon as you hear that cat, you know, let me know. Okay. How long did that last that I was sounding like a robot?
About 2-3 minutes.
So you waited 3 minutes. Okay. So as soon as you hear me doing that, tell me because I'll try to correct it. All right. So thank you for that. So let's keep. Where was I? What was the last thing you guys heard me say?
You were asking what's the difference between this black and gray
Yeah, okay, so
And
I
this
was talking about RGB, right? And what RGB means is that these have color, whereas the MNIST handwritten digits don't have colors. And so what that means is that though in RGB it's just a flat plane, X and Y coordinates, right? 28 by 28, that's it. But here with color images, these are not 28 by 28, they're 100 by 100 by 3. So they have that third dimension of the grids, okay? So one way of thinking about it is imagine that you have 3 DVDs, you know, one for the Matrix 1, the Matrix 2, the Matrix 3. If you put all 3 together, now it's not just one plane, it's a cube, right? You have 3 layers there. And that's kind of what it is, X, Y, and Z. All right, and so you have to account for that. So in TensorFlow, you need to represent these images not as a plane, but as a cube or even a higher dimensional tensor, okay? But so that's one thing to be aware of. So in possibly speaking, in terms of information, you don't have, like in MNIST, you have 28 by 28 by 1. Here, the dimensions are 100 by 100, so that makes them bigger. So that's 100 by 100, but now it's 100 by 100 by 3. Think about how large that is. So if you used all that data, what would be the dimensionality of your vector? How many features would you have, assuming that you treat every pixel as a feature? How many is that? How many features?
Would that be like 30,000 or something like that?
30,000, exactly right. Think about it. MNIST was 28 by 28, which is 784 features, right? If we treat every pixel as a feature. Here, if we use color images, it's 100 by 100 by 3. 30,000 features. Look at the dimensionality and how it exploded. Think about a model that has to find a weight for every single one of those features. That is a huge model. Weka and sklearn are completely out of the running at that point, right? And only TensorFlow can handle something like that. And even TensorFlow will have limits. Right now, Mitch and I are working on a project, and he knows this better than I do, but he can tell us. We're using color images. What was the limit of the images that we are using, Mitch?
300 by 300.
300 by 300 by 3, because they're color images. So think about that dimensionality. That's 300 by 300 by 3. That's 270,000 features. So as you can see, that gets pretty big really quickly, okay? And so that's kind of the limits. And we're talking about GPU boxes like the ones we have here in Scholar. So really, really powerful computers, state of the art, and those are still the limits. So imagine you guys know that an image that is 300 by 300 by 3, that's not really that much resolution, right? You know, in the world where you guys do these high definition, right? So that might say that, okay, but what if, so you're telling me that machine learning or deep learning or TensorFlow can't handle a movie, high definition. Is that what I'm saying? Or how would you approach the problem of images that are, 1,000 by 1,000 pixels, or really high by 3, high definitions? What would you suggest we could do to still apply machine learning or deep learning? What would you suggest?
I think we should go for deep learning.
No, we are using deep learning for sure, but I'm saying that the limit here is 300 by 300 by 3. That's 270,000 features. But what if you had images that are even larger than that? High definition images, 1,000 by 1,000 by 3. What could you do? Does that mean that those images are basically off limits, that you can't use deep learning on them, or what could you possibly do? Nobody? So we could downscale them, right? So we can basically, and that's one of the things that, you know, a lot of the libraries that we have available can do, is that before we run any algorithms on them, we can just grab in a for loop all the images. It might take a while, but we're going to take their dimensionality, which might be 1,000 by 1,000 by 3, and downscale it to, let's say, 300 by 300 by 3. So now the question that I ask you is, what's going to happen to, the question that I ask you is, what's going to happen to the images when you do that? When you downscale their dimensionality.
You lose quality.
You lose quality, right? And in terms of machine learning, you lose information. Okay, you're going to lose some information, but sometimes though, machine learning doesn't need all of that. It can actually do a lot with very little. All right, so just keep that in mind. So those are the suggestions. Another one is we could take the color images and just make them grayscale. I mean, if I made these grayscale, these color images, they could still look like an, you know, one looks like an apple, the other one looks like a banana, but just, or they look different, but they are just grayscale. All right, anyway, so that's basically what we're going to do today. Okay, so we're going to explore this. So I think, did I move these to the 520 folder? I did. Yeah, all right, so let's go ahead then and get started. So now I'm gonna open up the terminal. And like I said, you have the code already, so I'm just going to explain the code. Okay, so remember, so now you should be seeing the terminal. Yeah. Okay, so I started bash. I'm going to go to the desktop. There we go, and then I'm going to go to 520. Okay. All right, and then I created a new folder, TF2 Basics, which is what you just downloaded. All right, and so here's my code, okay? Here's my code that's available there. And so you can see I have basics, functional API, the images, which is what we're gonna be using, and I've got Keras. One thing, we might need to install a few libraries, okay? So that might be needed. And so we're gonna do that. Now, another thing, you know, we need to bring up the environment. So keep in mind, currently we are only doing TF2, TensorFlow 2. So conda environment list. I think, all right, there it is. So I'm just gonna I like to use TF GPU. So I'm gonna do that one. Conda environment TF GPU. Also, they showed me how to move this over there. All right. What happened? Oh, conda activate, sorry. All right. All right, or we can use the other TF2 environment. So now we are in the conda environment. So I'm gonna cd into basics. Okay. And you can see I have my, so example.py, I'm pretty sure this is what we covered, you know, about a week ago or so. So this one has been covered. Today, I'm just gonna continue with TF2 example. So one thing that like I've said several times, right? So there's a lot of the basic things about TensorFlow, and then there's taking those basic things and implementing an algorithm like linear regression or logistic regression or one of those. Now, I explained some of that last week when I was talking about the things that we need, and we will come back to that. But today, I'm really just going to lay out some ideas, okay? So basically, remember in machine learning, there's a pipeline from getting the data, pre-processing the data, getting the features, to doing the machine learning algorithm, running it, analyzing it. There's all of those boxes, right? So I think probably either at the end of class today or next week, we will get into the algorithms of machine learning. But today is more about the whole pipeline. So it's not just going to be that box ML, it's going to be the pipeline from beginning to end, you know, like taking the images and everything else. There's a lot of ideas that I'm going to throw at you. And just, you know, take notes. You know, you're gonna practice. The great thing about this is you can use all of this, and in fact, this is what you have to do for your term project. So the final term project really should, you know, I'm fine if you use Weka and sklearn, but the final project should be done in TensorFlow 2 with Keras, okay, and some kind of a supervised machine learning. All right. So anyway, so let's first of all start the TF2. So I'm going to open it with Nano. I'll do Nano TF2. So I'm going to open up this script. And there you go. So this script I already ran. And, you know, it's basically what I will do is I'm just going to start running it and explaining the different components of it. I strongly recommend that whenever you're learning an algorithm, type it up. That's usually, you know, sit down, type it up, see it, you know, working, etc. All right. So what I'm going to do is I'm just going to comment out a lot of it. Okay. And then we're going to take that approach. So I'm going to, for instance, I'm going to say, you know, I'm going to start here. Right. And I'm just going to comment out everything else. So I'm going to comment out from here, remember, just add 1, 2, 3, and then I'm going to go all the way down to the end. Right, and comment out everything down here. And I do have a few comments in there, so it might conflict, but let's see. All right, so I may just have to go line by line. I just don't really want to type up all of this. All right, so I really just want to focus on the very beginning. Okay, so let me do Control X, Y, and let's just run it. All right, so yeah, so there are some things in there that because of the comments it didn't like. All right, so let's go. I definitely want this to run and that to run. That can be out. All of this. Okay, so until about there is a comment. And that's commented out. Then here also. Well, about there. Then that part is also commented out. Then here, comment that out. Okay. Okay, all of this so far. Okay, so it's gotta be here. And then that's commented out, and then here again. Until there. It should just, this time it should work, hopefully. All right, so let's try it. And there you go, great. So usually this is why I like to do that print done, so I know when something has gotten to the end. So this way, we're gonna try this instead of typing this up, see how that works. All right, so now that I've done this, I know the code runs, and now I can remove comments as I need to. So let's go back to the script over here. All right, and you can see, so here I just have a few little comments, TensorFlow 2 ideas, Keras, and TF2, TF1 to TF2, all right? So the libraries that I'm using are import TensorFlow as TF, NumPy, OS, okay? Because the OS, we're gonna be reading files, the image files, right? And so we're going to need to have that. Right, then you can see over here, I have these, this is basically a comment, and I just left this out. So remember that, I think I've said this many times, many times, that it used to be TensorFlow 1. And now this has moved to TensorFlow 2. And so the fact that they've made this big change complicates things, because if I don't stress this enough, you know, some student said, I want to look for code online. What would happen is they might find some code and they think it's TensorFlow 2, but it's TensorFlow 1. If you don't understand this difference, you know, you're going to get really confused all the time. Okay, so apparently TensorFlow 2 does now include some mechanisms for dealing with using TensorFlow 1 in TensorFlow 2. You can see here, if you know, the session is a traditional thing from TensorFlow 1. We haven't seen this, but you will see it when we do the reinforcement learning stuff. And you can see that there are ways, you know, you have TensorFlow.compat for compatibility, version 1 session. And then these are ways that you can create things, then you can see it over here. I'm not using it at all in this code. I think I'm just going to be using TensorFlow 1 whenever I need to, and hopefully when they do TensorFlow 3, they will basically have both things in there. I just don't really like how they've done this, but anyway. So anyway, this is just an idea if you want to explore aspects of compatibility, or if you ever find code in TensorFlow 2 and you see things like this, you can tell, oh, they're using the session because they have this version. But we are not at all going to use it. So if you notice, all of this is commented out and you can ignore it pretty much. All right, questions about that, guys? Comments? No? All right, now one thing I should say, TensorFlow 1 was not very good for object-oriented programming. Okay, it was good for modular programming, it was good for other things, but it was not great for the people that really love to program in object-oriented programming. And so that's why Keras was created, to be kind of a wrapper around that, but even Keras was somewhat limited. So, you know, it's kind of a workaround. This time around, TensorFlow 2 has a very strong focus on object-oriented programming. And so that's one of the things that you will see in this style. All right, so now here we have TensorFlow 2, and this is TensorFlow version 2, and this is the style. If you notice, whenever we want to create a TensorFlow object, we use the TF term there. remember, one thing that you have to remember is that whenever you're coding, you are building what is called a computational graph, okay? And I think we talked about this in a previous lecture. A computational graph is a directed graph that consists of nodes and links, right? And the nodes can be either tensors, which are data, or operations. So the nodes can be either tensors or operations. And then the links are just the flow between things. So that's what you're doing here. So for instance, if you look, I'm creating 3 nodes here, A, B, and C, right? And they're gonna be actually, they're not even TensorFlow variables, they're just TensorFlow constants, right? With the values 1, 2, and 3, okay? These are the values. And by the way, they have names. Why do they have names? They have names because in the computational graph, and the names can be different. So this could be, for instance, ATF, and the other name is A. Why? Because A is the variable name in Python. ATF is the name of the node in the computational graph in TensorFlow itself. Now, the name is not required. You could actually do it without the name. Name is, you know, at TensorFlow, if there's no name, it creates its own names, you know, unique names. You know, let's say like variable 1A, 1B, and so on. It'll do it automatically. But if you want to give it a specific name, because later on with using something called TensorBoard or something else, you might want to look at the graph and you might actually want to look at the names. Okay, but just keep that in mind. So that's the first thing that might be confusing to you in TensorFlow 2, that these are Python variables, whereas these are the names of the nodes in the TensorFlow computational graph. Okay, and then the values are 1, 2, and 3 for this one. They're not even though everything is a tensor, these are basically, you can think of them as scalars. They're just one single value. Are there any questions about this, guys? Any questions? All right, now look at this operation. I have here in TensorFlow, you can do, especially in TensorFlow 2, you can do this type of operation. This is just an equation. So here I've actually created a node called Z. So think about it. Again, C is a variable in Python, but C represents a node in the computational graph. So what does that mean? It means that now imagine I have a graph of nodes and links where I have nodes A, B, and C, plus other nodes for multiplication, the minus or subtraction, and this is a plus as well. So I have those nodes as well in a computational graph, okay? So if you think about it, if I switch over to the whiteboard, you will see that those are, if I switch over to the whiteboard, let me move this. So please remember this and tell me what it is, okay? What equation? So it's A minus B times 2. Okay, so you should be seeing the whiteboard now. So C is A minus B. And then this is times 2. That's C. And then this was a plus, I remember C, I think. The values are 1, 2, and 3. So if we evaluate this, it should be 1 minus 2 plus 3 should be minus 1 plus 3. So this is minus 2 plus 3. C is equal to 1. All right. Additionally, what's important is that this creates a computational graph in TensorFlow, okay, where you have a node called Z, and C points to various other nodes. You have node, let's say A and B, and you create a minus node So in the computational graph, you know, you do that. And then the result of that is a multiplication with 2, a value that you just have in there, right? And then the result of all of that becomes a plus node with C, right? And then all of that is referenced by the C node. So whenever you call Z, so let's say you call Z at some point, it's going to, and then there's data in A, B, and C, you can evaluate the entire graph and get a result. Does that make sense, guys? And this is called a computational graph. That's called a computational graph. Is that clear?
Yes.
All right, great. Now, why, the question might be, why do we need to create this computational graph? Well, remember that the underlying background code is C, C++ because it's the most efficient code, and the CUDA libraries. So Python, which is an abstraction of C, C++, basically, what you do is Python allows you in a very easy way, because we all know how to write Python, to create the computational graph, and then TensorFlow takes care of making it into the C CUDA efficient binaries, and then all of that gets run. In fact, you will see one of the funny things with Keras, as we start looking into it, is that there will be a compile function. And so whenever, after we've created, laid out the computational graph, etc., we're going to call this compile, and you can intuitively, it kind of implies, you know, that, oh, this is where they're making that conversion. Okay, so that's, you know, that's the idea there. Okay, all right, so that's something that we will see shortly. Oh, before I forget, also creating the computational graph is called creating the architecture. Well, actually, the architecture usually is just a neural net, but the computational graph includes the architecture in it. Maybe that's a better way of putting it. So the computational graph includes. So our architecture would be a subset. So let's just say this part would be the, you know, the architecture. Somewhere in there, you know, oops, that's not at all what I wanted to do. I wanted to change color. All right, yeah. So let's say somewhere in there would be the architecture, but the computational graph is a little bit more than that. Okay, so hopefully I won't come back to this of computational graph, but I hope it makes sense. Okay, guys, that whenever I'm writing code, what I'm doing is creating the computational graph, and then the computational graph is done so that you can get the CUDA C++ code. Okay, so hopefully that makes sense. It's an important concept. But now I'm really just gonna, I'm not really gonna show the graph anymore. I'm just gonna be writing Python code, creating that graph, making sure everything is linked. So for instance, here we have a problem, right? These two are not linked. And so you need to make sure in your code that all nodes are linked together correctly. Okay, very important. So I'm going to go back to the here. All right, so that's what I was saying. So this creates, so maybe I can, you can, oops, as you are following along, you might want to just add a comment, you know, creating computational graph. Now, you know, keep in mind, because you always have these TFs, right? So whenever you're referencing these TFs, and then whenever you're linking them, and then you have this node, that node is also a tensor, so it allows you to access the whole thing. All right, so now that we've done that, notice we already looked at the tf.print command in TensorFlow 2. And so we can print my result z, which should be a number 1. Notice over here, I left for you guys to try out, play with, tf subtract for AB, play with tf multiply for 2 times some value, so make up some value there, and then tf.add. So play with these functions. Remember, I did say that in TensorFlow, there are 2 types of multiplication. Whenever you're doing, NumPy and TensorFlow, there's 2 types of multiplication, which are called element-wise versus the dot product, or, matrix multiplication is also a way of calling it. So usually the matrix multiplication or dot product is matmul. And whenever you see this one multiply, it'll be element-wise. That one is also equivalent to this one, okay? So this little asterisk or the function tf multiply, they're really the same, but they are element-wise multiplication. What that means is that the 2 elements that are being multiplied should have the same number of rows and columns, whether it's a scalar like here, or whether if one has 2 rows and 2 columns, the other one also has to have 2 rows and 2 columns. And that's why it's called element-wise, because it's on a per element basis. Versus mat multiplication, where the matrices can have different dimensions, but we will see that later. And that's an extremely important concept that comes from the linear algebra field. But don't worry about it. We'll do plenty of examples. So one thing I will say, don't try to memorize all of this. Make your notes, take this code, modify it like I did, add little comments here. Practice it, okay? It's like everything, like playing an instrument, right? You're learning how to play the piano. Read, but also play your piano. Eventually, some things will start to become clearer, okay? So certainly today, like I said, I'm not building any algorithms or any complex architecture. We're just playing with these building blocks, okay, of the whole pipeline. Later on, we will get to it, okay? So let's go ahead and run this, okay? So that's the first thing we want to do. We know this should give us a 1. So I'm going to go ahead, save it, and then I'm going to run it now. And there you go. Remember, all of this just appears at the beginning. Is all the information about the GPU. Notice that, yeah, I haven't done the update that Mitch suggested, so that this should show the GPU. I haven't done the update, so that's something I have to work on. But I guess I'll take right now as a pause to ask you guys, did you guys try Mitch's fix? And if so, did it work? I mean, I assume Mitch tried his fix, so it must have worked for him. But I just mean any other students in the class. Have you guys tried what he said? Mitch, do you know if anyone has tried it?
Off the top of my head, I don't remember.
All right, so no one has tried it, it seems. No one? You could say in the chat or something. So no one. So, all right, okay, let's see. I just want to know if it works for others. Kyle. Kyle is saying, I went through the video and it worked, but I'm pretty sure you have to type something in every time. Mitch, is that the case?
Yeah, you have to SSH into the GPU boxes if you didn't get assigned one.
Every time, okay.
Yep.
Right. But it seems like at least Kyle got it to work, so it's working. So that's good. So that's a reminder for all of us. I haven't done it either. Remember, so that we can get GPU processors on Scholar, we have to do what Mitch sent, okay? All right, great. All right, now that I've done this, let's go back to the code. All right, so we've gone over this. I've explained it, got it available. You're going to play with this, not as homework, but just practice it. All right, the next thing we want to look at is the idea of what are called function decorators. Again, I'm just really throwing this at you right now. So let's see. So here the comment ends there. So let me. Yeah, so I'm just going to put the comment here. And I'm going to now enable this one. All right, so what is this? Function decorators. You know, again, write it down. This is one of those quirky things that have to do with programming for TensorFlow, okay? Because as you know, there is Python code that you use to generate a computational graph. You know that that computational graph becomes, you know, the CUDA and C code and everything like that, right? All that process. You have what is called function decorators that you can use in TensorFlow 2. And this is something that you are going to use. It's also called autographing, right? As an autograph. Basically, what a function decorator does, by definition, is that it transforms Python code into a TensorFlow graph code efficiently. Okay? So efficient. So we will see that. Just keep that in the back of your head for now. But it's another way of doing this. So here, for instance, notice that what I'm creating is a function, right? I'm creating so really think if you just look at this part, this bottom part is just a standard function. And then what we are adding here is the @tf.function. And that's what is called a function decorator, right? So basically you do @tf function, and now what follows, the function that follows is basically, you know, the function being decorated. So you can see here, it's just standard Python code here. I create, define, compute C, A, B, and C. And then I'm going to call tf.subtract, for instance, AB, that gives me R1. Then I do tf.multiply of 2 times R1, and that gives me R2. And then I do tf.add R2 times C. Right? And that gives me Z, and then I return Z. So notice it's similar to what I was doing over here, right? It's just another way. Now I wrote it as a function, and you will see this as part of TensorFlow. And usually what people say, oh no, that's more efficient. Do it that way, that's more efficient. And so you will see that usually that function declaration will happen not throughout all the code in TensorFlow 2, but only in certain sections. And so it's one of those things that we kind of have to do to have more power and control over our graph, our computational graph, okay? So here you can see you have that definition, okay? So now down here, I'm going to actually move the comment further down to here. All right, so now, I have a bigger example of a function decorator. So I call this function compute C, just to have a simple example. Now I'm going to create another one called compute C2. Right? We're basically not going to use compute C. This one was just to illustrate. Now I go down here to compute C2. If you notice, it's the same thing, A, B, and C. Same thing, subtract A from B. Gives R1, then R1 times 2, multiply. That's a element-wise multiplication, gives me R2. Then we add R2 to C, and that gives me C, and then I return C, okay? So now, notice here that it's pretty much what I have over here, except that the function declaration, it's a little further up. You can see is tf dot function, and now it's got parentheses. You see there's open parentheses here, and then there's closing parentheses here. So usually I like to write this as you do in jQuery. Sometimes I have that bad habit. It's more readable to me. And then you can see what happened here is that now I do at tf.function, right? And I have, within the parentheses, I've added a new thing. And the new thing is called the input signature. And the input signature, what it does is it's basically a type of validation. So in the input signature, notice I have basically this type of tuple of 3 where I have 3 entries. I have this one, I have that one, and I have the other one. And what that means is that the inputs to the function, which are ABC over here, you see that ABC, right? Now, whenever, because this has been decorated by that TF function, and it has an input signature, now the code is going to validate that those 3 values are that specific type of thing. So here, what do I want? I want A, B, and C to be tensors that have a shape none. That means whenever you see the word none in TensorFlow, it means that it can vary. So none just means it could be 10 samples, 5 samples, 8 samples, whatever. It could be a vector, of several. It could be one value. So that doesn't do much. The shape is, but the thing that matters is that the data type is going to be int32. So it's tf.int32. So if we tried tf.int64, other things, it's not going to work, right? And TensorFlow will give you an issue. So you might think this is cumbersome right now, but eventually this does help, okay? And so we will see that later. So again, function decorators are this, so just keep that in mind, okay? Now you can see the function here, and now down here, we are actually going to go ahead and run it, right? So I have 3 entries in here, basically 3 prints, right, of calling compute C2, which has already been, it's the function. And then I provide various values, right? So in this one, I just provide, if you notice, just the three parameters, right? Basically 1, 2, and 3. Here, I specify 3 entries of scalars, 1, 2, and 3, because they are in square brackets. So they're basically vectors of 1 by 1, if you want to think of it that way. Whereas here, now I have something of different dimensions, right? So I have something of different dimensions here that I'm providing, okay? So different set of values. This basically has 2. It has, 3 and 2. So whereas this one only has 1 value, this now has 2. So let's go ahead and run all of these, and we can see what happens. So this one, the first one should error out because they're not, these are TensorFlow int32s, whereas this one should not be, right? So the first one should error out. So let's remove the comment and let's run it. Oops, that's not what I want to do. Okay, you can see here value error. So we can see what happened, right? So we have the, it goes over here. It called that print statement, right? Call that print statement here. And you can say Python inputs incompatible with input signature. Inputs were 1, 2, and 3, but the input signature wanted that, okay? And so it gives us an error. So that's really what the input signature is for, is so that you restrict the type of data, and that will become useful to you as you're trying to do more advanced things. So now I'm going to comment this one out, and instead I'm just going to run the other ones. Okay, I'm going to run the other one. So I'm going to do Control X, Y. Those two should meet the condition. The dimensions don't matter, but the data type should matter. So I'm going to run this. All right, and there you go. These are, in fact, TensorFlow in 32s. So you can see this one just gives 1, and then this one gives 9, 9, right? Because it's a vector. So we gave it, in the first example, gave it like scalars. In the second example, we gave it vectors, okay? That, you know, vector, as you know, has like an array of elements. This one had 2. Each vector, and they all had the same dimensions, okay? So if we take a look over here, you can see that there. All right, so does this make sense, guys?
Yes, it does.
Okay, great. So again, as I said, it's like we're getting into the water slowly, right? We're slowly getting into the water. I'm giving you a lot of ideas right now, and then we're gonna start building. So like Legos, I'm giving you certain pieces, build little things with them as we start progressing and building more things. That's really the way the 520 works with Keras and everything. When we do, if you guys take the deep learning class, that one's more focused on the algorithm, so focus a little bit more on really understanding the details of the algorithm. Also, I should say, next semester we're teaching ITS 265, I believe, which is a new course, and it's a course on literally Matplotlib, NumPy, pandas, and other things related to AI, artificial intelligence, a little bit of machine learning as well. So, you know, a lot more of playing with these matrices, you know, so certainly some concepts of linear algebra as well. It's a 200 level class, 265 for the new concentration in applied data science, but certainly something for you guys to consider. All right, so it's 3:24. So we're gonna take the 10-minute break. I'm gonna start generating this video, and then at 3:34 we will come back to continue, right? And this should be fun. So, you know, I think of this as power, right? You guys are getting serious power right now by learning these things. All right, so let's stop here and let's come back in 10 minutes.